Okay, let's just dive right into this. Welcome to This Explainer. Today, we're going to completely change the way you look at something you literally interact with dozens of times every single day. I'm talking about water. I want you to picture this brilliant, dynamic 3D map right in front of you. Over the next few minutes, we're going to use this map to zoom all the way in, like microscopic level in, on a single drop of water inside a local treatment plant. And then we'll seamlessly zoom all the way out to a satellite view of an entire global river basin. This whole spatial journey, it's exactly how we unlock the future of water management. So here is our roadmap. We'll start with the linear water crisis, explore the paradigm shift, and then structurally zoom through 3 levels: micro, designing out waste; meso, keeping materials active; and macro, regenerating natural basins. Finally, we'll rethink our water future. Section 1, the linear water crisis, the flaws in how we currently manage water. Let's kick things off with a pretty harsh truth. Much of the infrastructure we rely on today for water, the massive dams, the endless underground sewer networks, a lot of that was built decades ago. And honestly, it is buckling under the massive pressure of population growth and extreme weather. The results? Well, globally, 80% of wastewater is just not collected or treated appropriately. 80%. Just think about that for a second. We're living in an era where 90% of the global economy depends on water, and demand is expected to overshoot our supply capacity by 40% by 2030. Yet, we're just letting 80% of our used water slip right through our fingers. It's wild. The real root of this mess is our traditional linear approach to the economy. It's essentially take, make, use, and discharge. We take fresh water from rivers and aquifers. We make it safe for human consumption through treatment. We use it in our houses, our factories, our farms, and then we just discharge it right back out, often treating it barely at all, if ever. It's a single-use mindset applied to literally our most precious, life-sustaining resource. We extract it, use it once, and just dump it. So that old linear model, extract, single-use, dispose, it's highly wasteful and just fundamentally unsustainable. We desperately need a new framework. We have got to shift to circular water management. Instead of this straight line straight down the drain, circularity is all about continuous loops. We're talking about reducing water usage, removing pollutants effectively, reusing wastewater, recycling it for drinking, recovering valuable minerals and energy, and ultimately replenishing our natural sources. This is not just about saving water, you guys. It's about fundamentally rethinking water as a carrier of immense, incredible value. Section 2, the paradigm shift, a spatial framework for circular water. Inspired by the Ellen MacArthur Foundation, we can actually break this massive transition down into 3 spatial pillars. Step 1 is the micro level, where we design out waste and pollution right at the treatment plant itself. Step 2 is the meso level, keeping materials in use across a whole city or industrial region. And step 3 is the macro level, where we regenerate the massive natural systems that actually supply us in the first place. So let's make our first stop and see how this all builds together. Section 3, micro, designing out waste, zooming in on the treatment plant. At this micro level, the big goal is to transform water utilities from just, waste disposers into cutting-edge resource factories. And to pull this off, utilities are leaning on processes like anaerobic digestion. So what is that? Basically, by treating wastewater in an environment completely without oxygen, these very specific microorganisms get to work. They convert organic pollutants into biogas and sludge. That means they're literally turning human waste into a totally viable power source. How cool is that? And when it comes to actually cleaning the water, advanced membrane bioreactors, or MBRs for short, are an absolute game changer. Instead of relying on those massive old-school settling tanks, MBRs integrate micro and ultrafiltration membranes directly into the process. These membranes are so incredibly fine that they physically retain the tiniest particles. The result is water that is so clean it can be immediately reused for things like agricultural irrigation. And the best part? It takes up a mere fraction of the physical footprint of an older plant. Because this anaerobic process doesn't require pumping massive amounts of oxygen into the tanks, which, by the way, is incredibly energy intensive to do, it drastically lowers the facility's overall energy demands. But wait, it gets better. At the exact same time, it captures alternative energy, like methane, that can be used for electricity and heat right there on site. So you've got a treatment plant that practically powers itself. Section 4, meso, keeping materials active, zooming out to the city and industry level. Okay, now imagine we're zooming out from that single high-tech plant to a much broader regional view. At this meso-level, we rely heavily on what's called industrial symbiosis. That's a fancy way of saying one sector's waste becomes another sector's resource. For instance, reclaimed water from urban domestic use gets piped directly over to agricultural fields, or heat recovered from industrial wastewater is used to warm nearby homes. It's this highly collaborative, multi-stakeholder approach that squeezes the absolute maximum value out of every single drop before it ever returns to nature. So, what are the specific strategies making this regional resilience happen? Well, first, we're moving away from massive, highly centralized networks and shifting toward decentralized domestic wastewater systems. That puts the treatment way closer to where the water is actually going to be reused. We're also using wastewater for agriculture. They actually call it fertigation because that water still contains super valuable nutrients like nitrogen and phosphorus, so it acts as a natural fertilizer. Add in that industrial symbiosis where we share resources, and the fact that we're literally mining our wastewater to recover critical raw materials and thermal energy, it's just brilliant. Section 5. Macro. Regenerating natural basins. Zooming out to the global environment. Now for the ultimate zoom out. We're looking at entire natural river basins. Ultimately, all that localized microtechnology and that regional mesosymbiosis we just talked about, it all serves one massive goal: protecting the natural systems that keep us alive. We absolutely have to balance the water we extract with the natural system's capacity to supply it. By reusing water locally, we relieve a ton of pressure on our lakes and rivers, protecting their ecological health. And guys, this is crucial for our survival. To put it in perspective, in Europe alone, floods and storms caused almost $380 billion in economic losses over the past 50 years. Circular strategies combined with natural green infrastructure are exactly how we build up our resilience to mitigate those devastating climate extremes like massive floods and prolonged droughts. All of this brings us to a really crucial realization. Water should be as much a part of international climate discussions as carbon emissions and net zero greenhouse gas emissions. We talk about carbon constantly, right? But water is the primary medium through which we actually feel the day-to-day impacts of climate change. A climate-resilient society absolutely requires a circular water economy. Section 6. Rethinking our water future, valuing every drop. So we've journeyed on our 3D map from the microscopic membranes filtering out bacteria, through the complex industrial networks sharing resources, all the way up to the massive river basins that dictate our global climate resilience. But ultimately, making a circular economy work relies on you. So I leave you with this. How will your community rethink the value of every single drop of water? Will you continue to view it as just something to be flushed away? Or will you advocate for treating it as the incredibly valuable resource it truly is? The technology to close the loop is already here. Now it's time to build the future. Thanks so much for joining me on this explainer, and I'll catch you next time.